C.3, more addressing modes. The most part of the addressing modes we will cover here. We will cover 5 different addressing modes. In the previous video, we covered the first one. So the total, we have 6 addressing modes. All right, addressing modes number 2 and number 3. All right, so let's look at number 2. We call it immediate mode. So the most special property is this immediate. So what's the meaning of this immediate? So let's look at the meaning. First, a constant for an operand is encoded in an instruction. Here, we get to this constant. So what's the meaning of constant? So here, we need to use a constant as an operand. So this is the first way we use the constant. We can use constant in several different ways. So this is the first way we use a constant. We use a constant as an operand. So we know the meaning of operand, right? So when you do instructions, you apply operator and operator on multiple operands. So that is the operand. Now here, one of the operands is a constant. So that's the case. All right, so let's look at simple example. This example, add R4 comma hashtag hash, right? Many different way we call it. Hash sign, pound sign, right? Sharp sign. 3 different ways to call it. Okay, all right. Hash 3. Hash 3 or pound 3. Okay, all right. Or sharp, so you pound, Is it pound? I forgot. Several different ways. All right, All right. So here, here it means we use constant 3 here. So this is just notation. So this sign tells us we use this number literally. Just use this number in our calculation. Okay, All right. So the meaning, so you can guess the meaning of this instruction. The first source operand, 3, first. Second source operand comes from R4 register. R4, We use R4 address here so we can get values stored in R4 register. So we use that as the second operand. Then we do addition. After we get the result, we store it in the same R4 register. Override the old value. That's the meaning. This one. All right. So that's here we use the immediate mode. So this constant number, we refer to it immediate. So why immediate? First, we get the operand value immediately, right? So we call it immediate. So there are several other ways we cannot get the operand value immediately from the instruction. We need to do some other things, go somewhere else to get the value. So that's not immediate. Okay, so this way, immediate. So immediate mode. All right. Second, we call it displacement mode. Displacement mode. So what's the meaning of that? Here, the address is specified by adding a displacement. Here, we use a concept, displacement mode. Displacement. Distance from a reference location. Displacement. That's a displacement concept. Okay. So adding a displacement on a base address. So there is a base address. We do comparison, or we do reference against that base address. So which is stored, the base address is stored in a register. But when we need to get an operand, we need to add a displacement on the value stored in that base register, okay, to get a new address. Then at that new address, we get the value. That's the meaning. Okay, so you can see not indirect. Oh, not immediate, right? Yeah, here you can see you need to do many things. Finally, you get a value. Okay, comparing with our address symbol number 2, immediate, you get the operand value immediately. Here you do not get operand value immediately. Okay, yeah, you need to do several things, then you get a value. Here, let me use one example to explain this addressing mode. Yeah. Example is this. Add R4, comma, then 100. This 100 is the displacement. 100. Okay? Then parenthesis. Inside the parenthesis, that is our base address. Base register address. All right, so our reference point, base address. All right, so then this whole expression, the meaning of this whole expression, that gives us the address of our operand. Okay, so what is that? The address is 100 displacement plus the base address. So the value stored in R1 register, that is the base address. But we need to jump another 100 bytes. 100 bytes. This 100 means 100 bytes in the main memory. So you move the cursor another 100 bytes forward, then you get the address of your operand. That's the meaning. Yeah. So that is the displacement mode. So you can see, yeah. But this addressing mode is very popular. Yeah. So one of the most popular addressing modes. Yeah. So that's why we learned earlier. Yeah. Yeah. So the first three, the earlier we learn, the more important, right? All right, so the first, number 1, number 2, number 3. Most important, 3 addressing modes. Yeah. All right, so after that, then less and less important. Yeah. Next one. Yeah. All right. Addressing modes number 4 and number 5. Yeah. Number 4, it is called the register indirect mode. Register, but indirect, not direct. So register indirect. Yeah. So what's the meaning? The memory address is given as a value in the register. Okay. Yeah. All right. So in a register, we store memory address directly. Okay. Yeah. So after we get that memory address, we can get our operand. That's the meaning. Yeah. So let's see one example. Yeah. Add R4, comma, parenthesis R1. So this is the indirect register indirect mode. Yeah. Not direct mode. Yeah. Indirect mode. Yeah. Here, the address is stored in this as the value of register R1. Okay, so address is this one. Yeah. Then you get the value from the main memory. Yeah. So what is the value? Yeah. So value you can write in this way. Yeah. All right. So value you can write in this way. Yeah. Let me write here. Yeah. Memory. Yeah. So memory. We use this then this address expression. So that is the value expression. Yeah. So the first one is the address expression. The second one is the value of the operand expression. Yeah. But this addressing mode is a special case of the displacement mode. Just displacement equals 0. Yeah. You can imagine the 0, you put 0 ahead of that parenthesis. That's the, you can treat it as a special case of displacement mode. Yeah. So in that way, you can see we do not really need an independent register indirect mode, right? Because our displacement mode can cover the special case. Why we need to create a new, completely new addressing mode, right? Yeah. So that's why we say this addressing mode is less important. Yeah. All right, the next one we called direct or absolute mode. Direct, absolute. So what's the meaning of that? Yeah. Here, that's the meaning. A memory address is directly given in the instruction. In the instruction, we can find certain number of bits that represent a specific memory address. That's it. Okay, so that's the meaning. Yeah. All right. So let's look at a simple example. How do we represent it? Yeah. Here, it's easy. Yeah. We use the parenthesis around constant. Yeah. Here, the constant. Yeah. But that constant this time represents a memory address. Yeah. The meaning is just address equals this 1001. Yeah. That's the direct or absolute mode. Okay? Direct or absolute mode. Yeah. All right. Yeah. The last one, number 6. We call it memory indirect mode. Yeah. Memory indirect. Yeah. So what's the meaning of that? Yeah. A memory address is given in another memory location. So, nested reference. Yeah. Memory address given in another memory location. Okay, yeah. How do we represent it? Look at this example. Add R4 comma at sign. Here, this at sign, we use it to represent some special meaning. At parenthesis a register name. Address register location. Yeah. All right. So what's the meaning of that? The meaning is, first let's look at address. Address of the operand. So address, how do you find address? First, you go to R1 register to get its value. So that value, you use it. Go to main memory, find a value in that location, but that location actually just gives you the address of another address. That's not the value of your operand. That is just address of your operand. So you need to use that address to go to another location to get a value. So you see, nested relationship. So the value representation is like this. Okay? So you use another mem bracket, inside it, your address representation. So you can see, more complicated. Yeah. So using this way, you can get a little more flexibility, but you need to pay for the complexity. To handle this kind of complexity, your performance will be slower. Yeah, so you can see your performance will be slower. Yeah. So for that reason, we put this number 6. So we push this one as late as possible because we don't like this one. We try to avoid this one. Okay? Yeah. All right, so that's the 6 addressing modes we need to know for this class. But we use the first 3 addressing modes. All right, so let's finish C.3 video here.